Imagine you were running low on battery in an electric car, but instead of having to plug in to recharge and wait for the battery to refill, you could instead fill up at a pump in a matter of minutes with an electrically charged fluid, much like you would refill fuel for a combustion engine car. In this video, we'll see how this is possible and see what it could mean for electric mobility by replacing the need of lithium-ion battery packs. To understand this breakthrough liquid battery, it is first useful to understand the two technologies that it is based on. The first of these is the standard lithium-ion battery, commonly found in consumer electronics and electric vehicles. And the second is the redox flow battery, which stores the energy in the liquid electrolytes and is being used more and more in grid-scale energy storage. Lithium-ion batteries consist of a cathode, an anode, and a separator, which are all placed in an electrolyte fluid. When charging, electrons move from the cathode to the anode through an electrical circuit, and lithium ions move from the cathode into the anode material, storing energy. When discharging, the process is reversed, releasing stored energy to power devices or vehicles. Something important to note here is the reason lithium-ion batteries can store so much energy is because of the specially selected cathode and anode materials. On the other hand, we have redox flow batteries, such as the vanadium redox flow battery, which consists of two tanks containing liquid electrolyte solutions. The electrolyte fluids also serve as the anode and cathode because they have vanadium dissolved within them. This idea of a flow battery is the foundation of the new liquid battery breakthrough. However, it has one problem that ideas from the lithium-ion batteries from before can help solve. But as we delve further into the world of electric vehicles, it's important to remember that our online privacy and security need just as much attention, which is why I use private internet access, the world's most transparent VPN provider that will elevate your online journey on your phone, computer, tablet, or console. The VPN works by hiding your IP address through an encrypted tunnel, helping to keep your digital life secure. Just like how electric vehicles are helping us to unlock a more sustainable world, private internet access opens up a universe of entertainment options. Compatible with all major streaming services, this VPN allows you to access more content than ever, no matter where you are. You can also protect an unlimited number of devices at the same time, with just one subscription. And if you ever need help, their 24/7 customer support is always available. Their no logs policy has been verified in court, ensuring that your data is never recorded or stored. The best part is, if you use my link below, you can get an 83% discount when you sign up. That's just $2.03 a month, and you can also get 4 months completely for free. So sign up now, and thanks to private internet access for supporting this video. Now back to flow batteries like the vanadium redox flow battery we saw earlier. The big problem with them that means they can't be used in electric vehicles is their low energy density. For comparison, a vanadium flow battery stores about 1/10 of the energy of a lithium-ion battery of a similar size and weight. Thankfully, the breakthrough from a company called Influit Energy, which is a spin-out from the Illinois Institute of Technology, can change that. Remember I said the reason conventional lithium-ion batteries can store so much energy is because of the specially selected cathode and anode materials. Well, the reason vanadium redox flow batteries are poor at storing energy is because it isn't possible to dissolve enough vanadium into the electrolyte fluid, which is important as vanadium is the active material that stores the energy. This is why Influit Energy is instead suspending highly energy dense materials as nanoparticles in the electrolyte fluid, with their scientific papers stating this can increase the energy density by 30 times. This means their nano-fluid flow batteries are even more energy dense than current lithium-ion batteries and can benefit from extremely fast recharging, or should I say refilling. So let's look at this breakthrough energy system in some more detail. The idea of suspending electrode particles inside the electrolytes of a redox flow battery has been explored before, but a major issue has been that it makes the electrolyte too thick, Influit Energy say they have solved this by using nanoparticles which have modified surfaces to prevent the particles collecting together or sinking to the bottom. Because the active materials don't have to dissolve, much more energy dense materials like those used in current lithium-ion batteries can be used. If we look at the analyte and catholyte fluids that store the energy, we can see they are roughly the viscosity of engine oil. Another benefit of this is that the electrolyte fluid is also non-flammable, potentially making it safer in the event of a spillage. Though I would be interested to see what happens if the analyte and catholyte were to be mixed, as one of their publications with NASA states it would result in thermal reactions. In terms of operation, the nanoparticle flow battery is similar to the vanadium flow battery we saw earlier, except the electrons and ions are exchanged between the highly energy dense particles suspended within the electrolytes. Once the electrons have flowed through the required system, the discharged electrolyte is stored in the discharge tank. Say you wanted to recharge or refill your nanoparticle battery. You are left with two options. Firstly, you could just plug it into an electricity source and recharge it like you would a conventional electric vehicle. Or you could pump out the discharged electrolyte fluids and put in charged ones using the 4-nozzle pump designed by Influit Energy. This would also then enable refilling stations to slowly recharge the electrolyte fluid you just emptied out using intermittent renewable energy sources like wind and solar. Now let's see what they've achieved towards this big vision. Influit Energy has been working with NASA and DARPA, among others, and the key prototype milestones appear to be their Gen 1 and Gen 2 battery systems. Judging by their published work and messages I've had with the CEO, it seems like the Gen 1 system requirements have been achieved, which see a 23% increase in volumetric energy density over conventional lithium-ion batteries. I have also been informed that they developed a drop-in battery system for an electric utility vehicle that operated back in June of 2022, though publicly available details for this are yet to be released. A very small-scale demonstrator vehicle has been shown driving around their lab though, so I'm excited to see some footage of this in full-scale vehicles. The Gen 2 nano electrofuel battery prototype is set to be completed at the end of 2023 and promises to deliver energy densities 4 to 5 times higher than conventional lithium-ion battery systems. The Gen 2 battery system also promises to reduce the cost of energy storage to below $90 per kilowatt hour, compared to $140 per kilowatt hour for conventional lithium-ion battery systems and the Gen 1 system. Apparently, this will be achieved by utilizing an air cathode, which is a concept Tesla has been looking into for a number of years now. One key challenge for the team at Influit Energy is achieving high efficiencies. This is because there are some additional losses from using the pumps to move the electrolyte fluids. Therefore, the best way to improve this is to use highly efficient pumps and to keep the viscosity of the fluid relatively low while still keeping high nanoparticle densities. Clearly, the future applications for this system could be huge. Because of the high energy densities and rapid refilling times, it would be appealing to passenger car vehicles, long-haul trucking, and large utility vehicles. But excitingly, it may also increase the feasibility of longer distance electrical powered flight. As you're still watching, please subscribe to the channel as I think you'll like some of the other videos I make, like this one on toroidal turbines, which are being used in different applications to improve energy efficiency.